We are on page, I don't know, some page. 77. Functions and relations. All right, let's do this thing. 3 new words on this page, ladies and gentlemen. The first, oh, good gravy. You all see this, right? This isn't just me. Thanks, IT.
I really hope there's a day when we can't see what you're doing.
That would be hurtful.
That would be hilarious. Nice.
First new word, a set. All right. A set. Now, you've all heard this term before, except you know it from English class, where you draw a Venn diagram. Right?
No.
Yeah, you do. The characteristics of Bob, the characteristics of Amy, the characteristics of Jason. Then you write them all there, and there in the middle, if you have any words that are of all 3 of them, that's a characteristic they all share. You've all made a Venn diagram at some point.
I've made a Venn diagram for other things.
Great. Okay. Really? That was the only place we did Venn diagrams. Who are you doing Venn diagrams with?
Like science.
Oh, science. Barf. All right. So, I'm not really saying barf to science. Yay, science. I am all for science. I teach life, Aaron. Life.
Mr. Myers is anti-science.
All right. So.
No.
What?
No, completely different.
There is few people in the world less anti-Semitic than I. All right. A set is any. Please read that word and know it means any group of data. Anything. All right? So, it doesn't matter what it is. What is this? A bottle. That means this, the set of bottles in my hand, is 1. Because that is a piece of data. Does everybody understand? Now, how big is the set? 2. Good. A group of data. Excellent. The next thing is an element. An element is a single datum, which is the singular of data. A single datum, which is a single piece of info. So, in this white space here, elements are the parts of a set. Now let's put this into a real life example for you. Right now, can somebody name a set of things in this room?
A set of markers.
Excellent. A set of markers. Edward. A set of thank you cards. Lovely. Keegan. A set of tea. Well done. Simon. A set of gummy bears. Excellent. Javon. A set of desks. Carlo. A set of students. Excellent. Wayne. A set of boxes. Easy peasy, yes? All right. Now, can somebody in this room name an element of any one of those sets?
Green marker.
Green marker. Paige. A gummy bear. What color?
Red.
Don't say red. That's my least favorite. Green gummy bear. Keegan.
The silver teeth.
The silver teething. All right, so we're all good, yes? Everybody cool? Now, let me ask you this. Is it possible for you to take the set of people in this room and break it down into smaller subsets?
Yeah.
What would be a subset you would consider using? Keegan. The rows. Excellent. Javon. Gender. Excellent. Julius. Height. Ooh, you crazy. Nice. Sneaky. Carlo, dance? Okay. No. It's data. No, it isn't. It's data. End of discussion. Like, no, it can't. It is data. Okay? Data is only racist to people who are ignorant about what racism is. All right. Excellent. Can anybody think of another one? Pardon me? Okay. Weight. Age. Excellent. So we're all good at this. Good. Yay. Makes me so happy. Of course, the one I always like to use, and nobody said it. Somebody dabbled around with it with age, but nobody actually said it. Old people, young people. How many people are in the set of old people in this room? How many elements? One. Me. How many are in the set of young people in this room? All the rest is. Right? Now, of course, age is
Subjective.
Relative.
Yeah.
All right, so the third thing we have to talk about is a relation. Now, this is where it starts to get mathy. A relation is any time data from two sets are compared. Okay? Everybody cool? If you are comparing two different pieces of information, you have a relation. Sometimes those relations make sense, and sometimes they're idiotic. And I'm going to show you what I mean in a moment, okay? So let me give you an example that isn't idiotic. Are there a set of students? That was very grammatically incorrect. Is there a set of students in the room next door? Yes. Are those students sitting in desks? As are you, right? So could we compare the amount of students sitting in desks in each set? So that is a relation, okay? And it's a sensible one because those are two things that would make sense to compare. Everybody with me? All right. Now, I have to pause this right now because if I don't pause it, I put up some stuff from the internet that is copyrighted and YouTube got mad at me for it once. Here we are. Here I have a graph. A graph, and this is very important, ladies and gentlemen. A graph, and please notice I am capitalizing the word, represents data. It is not data itself, okay? It is a representation, a picture of data. Just like if some TOC came in here and grabbed one of my pictures from the back and slapped it on their forehead, they would not be me, okay? It represents data. Now, you can see here I have a graph. I'm going to take a quick moment to remind you, even though you already know this from your other classes, all the things a graph needs. 1, it needs a title. You have to tell me what the graph is. All right? 2, it needs an axis. 3, it needs labels. All right? And 4, it needs the data. Everybody cool? Everybody cool?
Yeah.
Okay. Now, you tell me what the two sets are from this graph. What would you say is set 1? Nino.
Dogs.
Okay, dog type. All right. How many elements are in that set?
6.
6. Dog type is the set. The elements are hound, chihuahua, which shouldn't even be on there because they're not a dog.
So prove it.
I don't know. But when I compare to a dog, which is that, to a chihuahua, anyway, lab, shepherd, malamute. Those are the elements, right? What is set 2? Edward. The height. And what are the elements of set 2? Nina.
Increments in height.
Not the increments. Pardon? The amount for each, right? So what is the first element in the set of height? No. No dog is 0 height. It's not a dog if it has no height. It doesn't exist.
Well, 11 maybe.
Yeah, something like that, right? It's not quite 10. It's a little past, yeah? So 11. What's next? 30. What's next?
45.
Call it 45. And then? Well, we've already got 45. So 60 and 80. Everybody cool? 2 sets, yes? Do I have a relation yet? Have I compared the two? On the graph I have. But in my elements, are they compared? No. If I start with hound, what is the relation? Hound is what? 60. Now I have a relation because I'm comparing an element of one set to its specific element in the other set. Everybody good? Okay, what's the next one? 11 or whatever we say, 11. Next. Corgi, which is 30. Then lab, which is 45. Shepherd, which is 45. And malamute, which is 80. Everybody cool? One set, second set, then a relation where the data is specifically related to the other data. Everybody good? Okay. That is a relation. Now, turn the page over. And another new word, function. Now, some of you may have seen this before. Think back to about grade 4 or 5, your math textbook, and you saw something that looked kind of like this. Just wait. Somebody has always seen this. You drop in a 7, plus 3, minus 4, and you get out what? 6. The function machine. Have any of you seen that? Yeah, a few of you will always have. Fewer and fewer every year, which is fine. The number that goes in, is that a piece of data? Is the number that comes out a piece of data? Are they related? Because whatever I put in here will give me a different number here, yes? Okay, this is a function. Now, a function, since I'm comparing two sets of data, is a function automatically a relation? Of course it is, because a relation is anytime we compare two sets of data, right? So a function is a specific relation in which one element relates to only one element in the other set. Now, in this example I have here, what would you say is the first element? 7. And that relates to what? 6. Everybody agree? Is there any number I could start with and end up with 6 except 7? No. So that makes this a function. Because no matter what I put in here, what if I put 8 there? What do I get out here? 7. What if I put 15 here? What do I get out here? Is there ever any repeat? So that makes this a function. Is everybody cool? I started with 7, so we call that an input. And I ended up with 6, so we call that an output. In a function, each input gives a unique output. Is everybody cool? All right, so let's go back. You don't need to write anything. Let's look here. What would you say the input on this graph is? Is it the dog height or is it the dog type? Dog type would be input. Because if I say hound, you will tell me the height. Yes? So, hound. Excellent. Chihuahua. Excellent. Corgi. Excellent. Is that a function? Yes. Each input gave a unique output. Yes? Everybody agrees? Okay. Lab. Still a function? Yes. Shepherd. Still a function? No. Why? Same output twice. Everybody understand? If I say to you, I need to know the height of a corgi, can you tell me? Yep. Because it's a relation. We're okay, right? If it's a function, it works backwards as well. I am thinking of the type of dog that is 30 centimeters tall. What dog am I thinking of? A corgi. Everybody good? Okay. I need to know the height of a lab. 45. Because it's a relation. If it's a function, it will work the other way. I am thinking of the dog that is 45 centimeters tall. What dog am I thinking of? That's not what I asked, Simon. I said, what dog am I thinking of? What is your guess? Nobody wants to guess?
Shepherd.
No.
Lab?
Wrong.
What? Oh.
Well, you asked me about shepherd. You were wrong. Then I changed my mind when you asked me about that. See, it doesn't work both ways. Does everybody understand? This is a relation. The thing with the numbers is a function. Everybody cool? All right, let's see if we can apply it. Each month of the year relates to a number of days. Are there two sets of data there? Okay, what is the first set of data? What is set 1? Months. What are the elements in set 1? Jan, Feb, March, April. That's as far as I need to go because it's going to prove it right here. What is set 2? What are the possibilities for days in a month? 30, 31, 29. There's 28. Right? Everyone agree? Well, 3 out of every 4 Februaries only have 28 days.
We play that in March. What about this year?
No, guys. This is just the data.
Oh.
This is not a relation yet, right? Have I compared the data? So I don't have a relation yet. When I compare the data, I'll use purple because blue and red make purple. January has how many days? Is that a function? Did I input something and get a unique output? Yep, because it's 31, right? Everyone cool? Okay. I'm going to skip February for a moment. March, how many days? No, I'm going to skip March for a moment too. April, how many days?
30.
Function? I input January, I got output of 31. I input April, I got output of 30. That's a function, isn't it? What happens when I put March on the table?
31.
Is that a function anymore? No, I'm thinking of a month with 31 days. You know which one it is? No. Okay. And February also ruins it, doesn't it? Why? Because it's 28 or 29. So this is a relation. Does everyone understand? Okay. Let's go to the second one. Every name on my class list relates to a student in my class. What are the two sets of data? What's an element in the first set? Pardon? Names in the first set? Okay. So I have names. Now, names is tricky, right? Do I mean first name? Do I mean last name? Do I mean both? Whatever. Okay. But for our purposes, right now, we're going to only use first names. Cool? So we've got Ahmad, Keegan, Carlo, and we can stop there, yes? What's the other set of data?
People.
The actual kids, right? So people. There's person 1. If I number the desks, right, you'd all be in a spot, yes? So person 1, person 2, person 3. Is this a function? If we go by first name only. Yes, because are there any kids in this class that share a first name? No. Okay, what if I go by last name? Are there any kids in this class that share a last name? Well, let's check. Uh-oh. So if I go by last name, is it a function?
No.
I am thinking of the kid with the last name Brar. Do you know which kid I'm thinking of?
No.
You don't. I could say, what's her last name? Brar, and it works, right? Or I could say, where is he? He's hiding. Where'd he go? Way over there. What's his last name? Does it work the other way? I'm thinking of the kid named Brar. Which desk is that kid in? You don't know. Everybody understand? Everybody cool? So, by first name in this class, is it a relation or a function? By first name. First name, it's a function. Because there's no repeats. Yes? Paige? No. Because I'm teaching. And I don't want to have to re-explain it later. Yes. That means that I will not expect to hear from you, where did that number come from, in 5 minutes? And I know I will. What about by last name? Then it's a relation, right? What about first and last name? Then it's a function, unless you're in the 12th grade in the school, and because we have 2 Jasreet K. Dillons, even down to middle name. All right, this is important. Highlight independent variable and highlight domain in the same color or circle them. Make them the same in some way. Then highlight dependent variable and range. The independent variable, which I will abbreviate as IV. The independent variable is the variable that stands alone. What do I mean by that? How old am I?
45.
Somebody knows. 45, almost. I'm 44 and like 11/12. Hint, hint, April 27th. It's a weekend. No, I think it's a Monday. It's a Monday. Lucky you. You'll be able to give me my presents in person. April 27th. Now, April 20, my age, is that a variable? Does my age change? Yes, every year my age changes. Yes, okay. I'm not that person who says, I'm 29 again. No, my age changes every single second, as does yours, yes? Right? Okay. So, does my age changes every single second, yes? If I wear a yellow shirt, am I the same age?
Yes.
I'll make it simpler. If I take a drink of this water, am I the same age? Am I still 44? Still 44? Okay. Does my age ever change? If I drink this water, does my age change? If I don't drink this water, does my age change? Is whether or not I drink the water something that changes? Yes, because I could drink the water or I couldn't. Everybody understand? Regardless of drinking this water, my age will not change. Everybody with me? So that makes my age an independent variable. Because no matter what else happens, it's going to be 44. Everybody with me? Now, what if I was comparing all of us? If we all had water in front of us, and I was comparing the amount of times you take a drink, is that a set of data? Okay. And your age, is that another set of data? Okay. Which one do all of us share right now? We all have an age. Do all of us have a bottle of water in front of us? No. So age is the independent variable. Does everybody understand? It's the variable that stands alone. The dependent variable, and I will write this in blue, the dependent variable, or the dv, is the variable which changes when or if the IV changes. Everybody good? Okay. Now, why have I highlighted domain and range in the same colors? Because the domain is, and this is really careful, you got to understand the difference here. The domain is the set of data that goes with the IV. So, remember back here in our dog type, we labeled this is the set, this is the data, yes? So, the set of data that goes with the IV and the domain are the actual elements. Okay? So, if I brought a chihuahua in here, which I never would do, if I were to bring a chihuahua in here and put it on this desk, it's a chihuahua, end of discussion, right? We could measure its height, we could measure its weight, we could measure how many hits with a hammer it would take to... I'm just kidding. I would never hurt an animal. I'm just joking. I'm just joking. I don't know that because I always end the sentence with that. We could count a whole bunch of stuff about the chihuahua, couldn't we? But would the fact that it's a chihuahua ever change?
No.
No. So that is an independent variable. Could we bring in another dog?
Yeah.
So the variable can change, But whatever dog I bring in, it's that. Everybody with me?
Yeah.
So the dog, 1 second, Julian, the type of dog is the independent variable. What's the domain? Hound, Chihuahua, Corgi, Lab, Shepherd, Malamute. Everybody understand? The set is the independent variable. The domain are the actual elements. Everybody good? So let's keep that rolling. The independent variable was the type of dog. And the set, or the domain, was Hound, Chihuahua, Corgi, Lab, Shep, and Malamute. Everybody cool? Everybody good? Now, Julius, your hand was up. What?
Okay. But what if you change the Chihuahua's genetic code? Then it's
Julius, do I have time for this?
No.
Come on. Aaron, your hand was also up. Your hand went up and down and up and down. Did you just... You're good? Okay. So obviously, what's the range? If the domain is the set that goes with the ivy, what's the range?
The set that goes with the variable.
Yes, set of data that goes with the...
Dependent.
Yes. That goes with the DV. Those actual elements. So what's the domain in our previous one? The domain is height, right? What is the actual domain? What was the lowest one? 11. There is no dog that is 0 centimeters tall. 11, 30, 45, what was it, 60, and 80. Is everybody cool? Everybody's good? Now, listen carefully. 99% of the time, yes, we put the domain on the x-axis, which means, where is the range? On the y-axis. Now, all of you remember which is x and which is y, right?
Yes.
That is x, that is y. 99% of the time. Sometimes we turn it. So you have to actually also know the definition. You can't just say, oh, the x-axis is the domain. Everybody cool? Because wouldn't it be just as legitimate to draw the graph this way? Hound, Chihuahua, Corgi. That's the y-axis, right? And have 60, 11, 30. Does that graph also make sense? Yeah, but you wouldn't say that the height is now all of a sudden the independent variable, would you? Everybody cool? All right. Now, Paige, I'm done new stuff. We're going to be doing examples now. Yes, I'd rather you didn't, but I'm not going to stop you. But we are going to apply what we just learned. All right, now you can tell right away by looking at this how old this is, right? It's back, minimum wage was $9.50 an hour, but it doesn't matter. So, Sandy's getting a job at Flying Witch Pizza, which also doesn't exist in Abbotsford anymore. It used to be over by the Shoppers Drug Mart and Original Joe's, but it is now gone, which is too bad because Flying Wedge is absolutely delicious pizza, but we don't have it here anymore. Paid $9.50 an hour. Her hours worked are related to her pay per week. That's a relation that makes sense, yes? If I work, I'll get paid, yeah? Okay, let's talk about the independent and the dependent variable. First of all, what are the two variables? What are the two things that can change? Edward. The wage is going to change? She's paid $9.50 an hour. So is her wage going to change? It says right here, Edward, she is paid $9.50 an hour. Is that changing? No. The hours that she works could change, right? Maybe 1 week she's sick and doesn't work as many hours. What's the other thing that could change? Keegan? the amount she is paid. She is always going to be paid $9.50 an hour. All right, so now we've got our two variables, right? We have our two sets of data. Set 1 is our hours. Set 2 is our pay. Which of those would you say is the independent variable? Pay is independent, and Gervier says hours is independent. All right, let's do a quick comparison. How many of you have any idea how much you pay for a car repair?
400.
No, per hour.
Oh, per hour? No.
You guys don't do car repairs. That's bad. How many of you have heard a joke on a TV show about how much a lawyer charges per hour? Right? Like $500 an hour, right? You've heard that, yeah? Okay. Did Sandy work for an hour?
Maybe.
If Sandy works for an hour, how much is she paid?
950.
A lawyer in the law office right above Flying Wedge works for that same hour. How much does he get paid? 500. Which of those was independent? The hours. Everybody understand? So, hours is our independent variable, which I believe I wrote in green. And our pay, which I believe I wrote in blue, are our dependent variable. Because our pay depends upon our hours worked. Everybody understand? Did I go work at Flying Wedge this week? Did hours pass for me? Yes. Did Flying Wedge pay me any money? No, because I didn't work there. So my pay from Flying Wedge depends on the hours I work there. Everybody good? Okay. So now we've got our IV and our DV. What is the domain and range? So the domain is the actual set of numbers that it could be in a week for Sandy. Now I'm going to give you some rules here. You have to work 4 hours a day. That's the minimum amount you can work by law. So what is the minimum amount Sandy could go to work in a week? No. Does Sandy have to work? So what's the minimum amount she could work? 0. Because she maybe didn't go to work. If she goes to work, what's the minimum amount of hours she would work? 4. Right? And then could she work 5? 6, 7, 8, 9, 10, 11, 12? Up to what? Who knows? You can work 40 hours a week. Okay? So 4 to 40. Everybody understand? Everybody cool? Now, for our purposes, we're just going to say 0 to 40. Because you are allowed to work less than 4 hours if you agree to it. Everybody with me? So that is our domain. How do we write that? Like this. What is the lowest amount we could have? 0. Which is less than or equal to our hours. We put our IV in there, which is less than or equal to what? What's the maximum amount we could work? 40. So we put our lowest domain value, then what our domain is, then our highest domain value. Everybody cool? All right. The range is trickier. Now, first of all, we are going to assume she can only work full hours, right? So this means her hours, and I use this funky little e, are a set of, not integers, sorry, whole numbers. 0, 1, 2, 3, 4, 5, right? She isn't going to work any decimals. Everybody cool? All right. So what then are our range values? If she works 0 hours, her range could go from 0 up to what? 380. because that's what 40 times 9.5 is, yes? Now this is where it gets tricky. Can I fill it in this way? Could she be paid $14? Why not? She can only work full hours. So what is the least amount she could be paid? What? 0. And then what's next? Then what? 19. Then what? Then what? Everybody understand what I'm saying here? This can be every whole number from 0 to 40. But this is not every number from 0 to 380. Does everybody understand? Cool? It would be in here multiples of 950. Is everybody cool? Okay. Now, is it a function or not? Guervere says yes. Guervere is almost always right. Everybody agree? If I work 9 hours, am I going to get paid or 10 hours? Am I going to get paid $95? Is there any other way I could be paid $95? No. So every input of hours yields a unique output of pay. Everybody with me? So this is a function. Now I know we're talking a lot today, but we've had a lot of little breaks. And you know, of course, I'm not going to give you any homework. So we're not even going to get through all this today. All right. Everyone is good? Okay. Now we only have numbers. That first number there, 1. Number, comma, number is what type of notation? Where do you see this? Number, comma, number. Where have you seen it in the past? Graphing, right? What are those ones? Those are X's. What are those ones? Y's, right? Which means X's are our IV or DV? IV. And our Y's are DVs. So, I want to know if this is a function. How do I check? Every IV has to give me a unique DV, yes? So what is my first IV in here? My first IV is 1. What's its DV? What's its output? 3. Then what? 2, 6. Then what? 3, 9. Then what? 4, 12. Does every input give me a unique output? So is this a function? It's a function. What is the domain and range? The domain are which? It's the set of which? IVs or DVs for domain? IVs, domains, they're green. What is my lowest domain? 1. What is my highest domain? 4. Right? And in the middle, 2 and 3. So I could write it this way with these squiggly brackets, the devil horn brackets. That's one way I could write it. What's the other way I could write it? I already showed you. 1 is less than or equal to X, which is less than or equal to 4. And X is a set of what kind of numbers? 1, 2, 3, and 4. Are they wholes? Are they naturals? What are they? Those are whole or natural, right? And then you know that could X ever be 1.25? Why not? Because 1.25 isn't whole. Everybody cool? Okay, what is the range then? The DV, which is blue, and they are 3, 6, 9, 12. Now this is where kids screw something up. Can I write this way? No, I have to write it this way. And once you have separated them, you cannot automatically assume that these are pairs, even though in this case they are. Everybody with me? Think back to the dog one. The lowest number was 11. but our first input was hound. Would hound link up with 11? No, if we wrote it out, we'd have hound, chihuahua, because that was the order, right? But then if we wrote our ranges, the lowest was 11, and then it was 30. Do either one of those match up this way anymore? No. Everybody cool? Gervir.
Can't you write the 3 and 12, but right and never goes below 3?
You wouldn't, is all I'm saying. I only did that with the 950 to show you what was happening there. And I see people packing up, and I'm cool with that. We're going to continue with this at a future date. What does that mean? I don't know.
It means 4 years from now.
It could. I wouldn't bet on that if I were a betting man.
Are you a betting man?
Do you think I'm a betting man? Are you willing to bet if I'm a betting man?